All right, so our final primary tissue type is connective tissue, and it is all over the body, has a wide variety of functions. So it supports the body, it protects the body, it binds tissues together, holds organs in place. And like I just said, it's everywhere, the most abundant tissue in the body. With one exception, it's vascular, so it has its own blood supply. And then all connective tissue has what's called a matrix that's non-cellular and non-living between the cells. And so we'll talk about that matrix in different types of connective tissue. Okay, so this is the widest variety of tissue types we're going to see in the body. So one specific, or the first specific tissue type within connective is called loose or areolar tissue. Sometimes you even read loose areolar tissue. So it surrounds the organs, wraps around them, holds them in place. It consists of elastic and collagen fibers, and we'll look at that a little more closely on the next slide. And then it also has what are called macrophages, which are phagocytic cells that are going to surround and engulf pathogens, eat things that are pathogenic essentially in this tissue, and eat up cellular debris. Okay. And if you don't remember from biology that phagocytosis is when you've got a process of taking in food into the cell. PHAG means to feed, okay? And so these cells will surround and engulf foreign particles, right, that are pathogenic or cellular debris. Collagen and elastic fibers are shown on this slide pretty well. So you can see a nucleus here. Okay, and then the collagen fibers versus the elastic fibers. So collagen is thick, right? This is what makes your skin nice and firm when you're young, and then as collagen starts to break down as you age, and that's when you start to get wrinkles. Elastic fibers, they are thin and stretchy, so think like a rubber band. This is what allows loose areolar tissue to kind of bounce back into place, okay, when it stretches. Okay, so our second specific tissue type within connective tissue is dense tissue or fibrous connective tissue. There's two different types, and pictures are on the next two slides. So your dense fibrous connective tissue has lots of elastic fibers and collagen. It's very solid and dense looking in appearance. It supports and connects. It's got a very poor blood supply, so healing is really slow. For example, tendons and ligaments, if you've ever had a tendon or a ligament injury or tear, then they're pretty slow to heal a lot of times, especially as we get older, they're slower to heal. Okay, so let's start with dense, regular connective tissue on this slide. Okay, so this is going to make up tendons and ligaments, for example. If we look at this picture on the left, notice that all the kind of wavy lines are going horizontally across the slide. So in this particular type, the dense regular, the collagen fibers all run in the same direction. And this is really important in a tendon and ligament, which this might be kind of small on your slide. It says tendons and ligaments must be strong and stretchy to resist linear forces, so the fibers are going to run in one direction. So when we talked about forces in the first unit, okay, picture a stretching force, for example, okay, that's essentially what your tendons and ligaments are under. Within a linear plane, they're designed to stretch in one direction. Well, if somebody has an injury, like a tear to an ACL or an MCL in the knee, it means that that linear movement changed, and it, instead of going in one plane, it went in the opposite plane and caused that tear, like a 90-degree plane. Okay, so if you're thinking of your patellar tendon, for example, okay, right in the middle of your leg, okay, where your knee attaches to your tibia, that needs to move in just one direction, okay, as you're walking down the hall. You don't need for that to be torn and to move horizontally, right? So this is to resist linear forces. So again, the fibers are going to run in one direction. Nice and compact looking as well, okay, very dense, hence its name. All right, then we've got in this picture dense irregular connective tissue. So the collagen fibers do not run in the same direction. So down underneath that again, you probably can't see very well on your copy, it says dense irregular connective tissue. It attaches to the skin, to underlying muscles and bones. So this is going to be part of your skin, for example. And if you just, as you're sitting here listening to this, if you wiggle your fingers around, like kind of spin your thumb around in several different directions, if you think about the fact that the collagen fibers are going to run in a lot of different directions, it's because this tissue is going to move in different directions as part of your skin. Okay, so it says it's always fibrous with lots of collagen. The forces acting on these tissues come from multiple directions, so the fibers can't run in just one direction. Okay, so that again, I'm just going to use your skin as the one single simple example here, that's going to allow for your skin to move in lots of different directions to deal with lots of different forces. Okay, then the next type is adipose. Okay, so adipose tissue, this is what we often call fat. Okay, so it's filled with lipids, okay, or filled with adipose. So this cell, for example, okay, there's the nucleus for that cell, there's the nucleus for that cell. The nucleus gets pushed off to the side because everything in this cell is a lipid, okay? And so this is, all the other organelles got pushed off to the side as well. So this is for insulation, protection, which would be cushioning and shock absorption, long-term energy storage, okay, and this is everywhere in the body, of course. It's just that it's in different concentrations in different people, of course. Females, for example, we have more in our hips, okay, and breast tissue. Males in general, it kind of tends to be a little bit more evenly distributed unless somebody just has a higher percentage of adipose, just maybe due to poor diet and lack of exercise or things like that, okay? And so this is considered a solid matrix still. So far everything, I haven't said this yet, so far everything we've discussed has been a solid matrix, but this is like a soft solid, okay? Okay, so adipose tissue, I just said, was a soft solid. It kind of looks like marshmallows to a lot of people in the picture. Now we're going to shift gears to a firm matrix. All right, so cartilage, and there's several different forms of cartilage that we're not going to get into a ton. Okay, so you've got elastic cartilage, fibrocartilage, and hyaline cartilage. They all have cells in a firm yet flexible matrix. They're all avascular, okay, so it doesn't repair and heal, and scar tissue is going to form. It's got several different functions depending on the location. So, for example, it reduces friction, the cartilage that makes up the covering of the ends of our long bones between our joints, like at your knee. You've got your femur is going to make contact with your tibia. And so you've got cartilage that lines the ends of each of those bones where they make a joint. This is also going to make up your nose and your ears. If you'll sit there and just wiggle your nose and wiggle your ears, then that is a good location to talk about cartilage. And then it's going to be protection as well. So it makes up the discs between the bones in our vertebral column. Okay, and so there it's going to cushion and absorb shock, and then also prevent friction between the bones that make up your backbone. So a couple things here. So this is probably easier to see exactly what I'm talking about on this particular slide. So where that arrow is pointing, okay, and this is just elastic cartilage versus hyaline cartilage. So where this is pointing though, this arrow, that circle, okay, that's darker, that's the nucleus. Okay, and actually, why don't I just label one over here? Okay, so that's a nucleus. Inside, notice there's a little light ring around that nucleus. Inside, what's called a lacuna. And we're going to see that again in our next type of tissue as well. It's just going to appear different. Okay, so the nucleus is inside of this little holding chamber, essentially called a lacuna, right, in cartilage. And so this is, again, solid matrix, firm and flexible. Everything's been solid so far. Now we'll go to our most solid, our hardest tissue, which is bone, okay? So here the cells are in a rigid matrix. The cells are called osteocytes, the mature bone cells are, and they are inside lacuna as well. This is, of course, your skeleton, all of the bones that make up your body. And this is sometimes called osseous tissue. Let me write that as well. Osseous. Okay, so support and framework for the body. It's this is going to act as levers for our muscles when they contract, okay, to help propel us around in our daily activities. So I always say this looks like a cross section of a tree where you can count growth rings on the tree. We'll talk about what all of this really means when we get into the skeletal system a little bit more. But basically, these little dark spots, okay, that's the lacuna. The osteocyte is within that lacuna, but it doesn't look the same way it does in cartilage. It just looks like a little black line, okay? But there is a cell in there. It's just the way that it stains on a microscope slide that you can't see the cell separate from the lacuna. So if we go back to this cartilage picture real quickly and how we can easily see a nucleus, I wrote nucleus there. That needs to say cell. Glad I did this. Okay, so this is the chondrocyte. Let's rewrite that. Okay, so everybody do that for me. All right, so the chondrocyte inside the lacuna. Sorry about that. Okay, so that is much easier to see. The living cell inside the opening here, it just literally looks like a dark line. So that dark line is the lacuna, and within that little dark line is going to be the osteocyte. All right, so then our final type of connective tissue is blood. This is our only liquid connective tissue. So we went from our hardest tissue, bone, to our only liquid tissue. The liquid matrix is called plasma, and it surrounds the cells that we see here. And we'll obviously get into this more when we cover the cardiovascular system. So we've got erythrocytes, which these are red blood cells. That's what RBC stands for. We can see those here, okay? They are going to transmit oxygen and carbon dioxide, taking oxygen to tissues and then removing carbon dioxide as a waste product. And then our leukocytes are our white blood cells. There's 5 different types of white blood cells, and they all play a role in the immune system and have different functions. So the 5 different types all have each kind of a unique function. This, for example, is bacteria being surrounded and engulfed by a phagocytic leukocyte. And then the last type of cell is a platelet. So these are what are going to clot our blood. So we can see a lot of erythrocytes or red blood cells around a little platelet just in a diagram. Okay, so when we go back to our homeostasis content from our first semester, and we talked about the fact that if you fall down and scrape your knee, that's going to send a signal to your body to bring platelets to the area. Okay, more platelets come, more signals get sent to bring more platelets, to send more signals to bring more platelets until you form a scab. Okay, and so then here, last slide, you can see red blood cells are going to be much more abundant than both platelets and white blood cells. So on this side, all of these lighter pink circles, those are red blood cells. That's a single leukocyte or white blood cell in this field of view, and then a bunch of platelets. Okay, and then over here, all of these pink circles that look about the same, those are all red blood cells or erythrocytes, and then this, and this. Those are all examples of white blood cells or leukocytes. Let me know if you have any questions.